Hello, everyone, and welcome to the Geostrategic Pulse. Thank you for watching or listening. One aircraft, 20 nuclear-capable missiles, and it's been sitting in America's arsenal since 1982. That's not a movie plot. That's a real B-52 bomber right now, carrying a weapon most people have never even heard of, and Boeing just got paid $50 million to keep it flying for 7 more years. So why is a 44-year-old missile still this important? Why can't it be replaced yet? And what happens when a single plane can strike multiple targets at once? Stick around, because by the end of this video, you're going to look at that old bomber very differently. Before we dive in, if military tech like this blows your mind, smash that like button, hit subscribe so you don't miss what's coming next, and share this with someone who needs to see it. And I want to know, does this make you feel safer or more nervous? Drop your honest take in the comments below. I read every single one, and I want to hear what you think. All right, let's get into it. So looking at the latest news from June 30th, 2026, Boeing just landed a $49.5 million sole source contract. And the whole mission for our deep dive today is to really figure out the geostrategic why here. Like, why is the U.S. military actively choosing to reverse engineer and remanufacture 1980s technology?
Right, rather than just buying something new.
Exactly. Why not just buy modern tech?
Well, it's a perfect question, and to answer it, we really have to look closely at what they're actually sustaining. Because you can't understand the geostrategy without understanding the mechanics of the weapon itself.
Makes sense.
We're talking about the AGM-86B air-launched cruise missile, or the ALCM.
The ALCM.
Yeah, and it has been the absolute backbone of America's airborne nuclear deterrent since 1982. And the raw specifications here are pretty significant. You're looking at an airframe that's 6.32 meters long.
So just under 21 feet.
Yeah, but with a 12-foot wingspan, once those wings actually deploy. And it weighs about 360 kilograms, so right around 3,000 pounds.
Wow. And the payload is the real story here for me. The latest updates specify it carries the W-81 nuclear warhead.
It does.
But what really jumped out at me is that it has a selectable yield ranging from 5 to 150 kilotons.
Which is massive.
Right. And to unpack this a bit for you listening, selectable yield means the military can literally dial the explosive power up or down before launch, like depending on the target.
Exactly.
And just to ground those numbers in reality for a second, the bomb dropped on Hiroshima in 1945 was about 15 kilotons. So the high end of this one missile is roughly 10 times that destructive force.
10 times, yeah. And that selectable yield is a really crucial part of modern deterrence because it provides escalation control. You aren't just wielding one giant inflexible hammer.
Right, you have options.
Exactly. It complicates the adversary's planning because the response can be scaled. But the sheer destructive power, that's really only half the equation here. The delivery mechanism is what really creates the geostrategic headache for any adversary air defense network.
Okay, let's unpack this, because a single B-52H Stratofortress doesn't just carry one of these missiles.
No, not at all.
It carries 20 of them. They strap 12 externally on these underwing pylons, and then they load another 8 internally on a specialized rotary launcher inside the bomb bay.
That's a massive payload.
Yeah, and I see people sometimes call this an omnidirectional sniper rifle, but I don't think that really captures how this works. A sniper rifle fires one highly directional shot. What this actually does is make the bomber less like a traditional warplane and more like a flying aircraft carrier.
Well, that's a great way to put it.
Right. It parks miles away and launches its own fleet of autonomous, low-flying drones that fan out to 20 completely independent targets.
Yeah, that flying aircraft carrier analogy is incredibly accurate. It's what we call a launch and leave architecture. Because, the B-52H is a massive, totally non-stealthy aircraft.
Oh, yeah, it's huge.
Right. If it flew directly into heavily defended airspace today, it would be highly vulnerable. But because the ALCM has a range of hundreds of kilometers, the bomber can release its entire payload safely outside the range of most adversary surface-to-air missiles.
So it just drops them and turns around.
Exactly. It turns around and flies right back to friendly airspace. Right. The bomber never even crosses the most dangerous thresholds.
Okay, but here's where I have a major question.
Yeah.
And honestly, where I have to push back a bit on the logic of this entire program.
Okay, let's hear it.
The airframe design is from 1982. We are in an era where adversaries are fielding hypersonic missiles that travel at Mach 5 or faster, right?
Sure, yeah.
And the ALCM is powered by a Williams F107 WR101 turbofan engine. It puts out about 600 pounds of thrust and cruises at roughly 550 miles per hour. that is subsonic. That's basically airliner speed.
It is.
So how does a 40-plus-year-old 550-mile-per-hour relic survive modern, highly advanced airspace? Like, isn't it a massive liability regardless of how cost-effective it is to maintain?
Well, it's a very fair skepticism, but what's fascinating here is how the mechanics of radar actually come into play.
Yeah.
See, the ALCM doesn't survive by outrunning interceptors like a hypersonic weapon would. It survives by hiding. And the way it hides is just a masterclass in Cold War engineering. First, you have the physical shape. It has very small dimensions and careful shaping that gives it a really low radar cross-section from the front.
Okay.
But the real magic is how it navigates.
You're talking about the terrain contour matching, right?
Yes, TERCOM.
Yeah.
Because, how does a 1980s missile fly blind without relying on modern GPS? Especially since GPS can be jammed pretty easily now.
Right. So what does it do?
It flies right on the deck at extremely low altitude. It has a radar altimeter pointing straight down, continuously pinging the ground to read the hills and valleys below it.
Wow.
Yeah, and it takes that real-time 3D topographical map and matches it against a preloaded digital map in its internal memory.
So it knows exactly where it is just by, feeling the shape of the earth beneath it.
Precisely. And because it's flying so low to the ground, literally weaving through valleys and using mountains as cover, it hides in the clutter of enemy radar.
Ground clutter, right.
Yeah. Ground-based radar systems have a really hard time distinguishing a small, low-flying missile from just the background noise of the Earth itself. So you combine that terrain masking with inertial navigation, and you have a subsonic weapon that can still reliably slip beneath the radar coverage envelopes of many modern defense networks.
Okay, that actually makes a lot of sense. I can see how the airframe itself is still tactically viable. But that brings us right to the core of this $49.5 million Boeing contract.
Right. The latest info.
Yeah, because the physical metal and the jet fuel might be fine, but the latest updates point out a critical flaw, the brain of the missile.
And this is the obsolescence problem. The flight controller, the electronic brain that manages that terrain navigation we just talked about, throttles the engine and handles terminal guidance. It was designed around circuit boards from the early 1980s.
Which is ancient in tech years.
Exactly. Those specific components just do not exist commercially anymore. The supply chains are completely dead. The companies that made those capacitors and chips 4 decades ago might not even exist today.
So if a circuit board fries in one of these missiles in 2026, you can't just order a replacement part from a catalog.
No, you definitely can't.
But wait, why can't Boeing just take a modern microchip, something from a smartphone that costs a few dollars and has 10,000 times the computing power, and just drop it into the missile?
And that right there is the aha moment of this entire deep dive. It's the friction between analog and digital technologies.
Yeah.
You cannot just slap a modern microchip into a 1980s missile.
Because it's too fast.
Yes. Modern chips process data millions of times faster than 1980s chips. If you put a 2026 processor into a 1982 flight controller, the new chip sends instructions so fast that the physical analog engine valves and flight control surfaces literally cannot react in time.
Oh my God.
The timing gets completely desynchronized.
Wow. So the brain would basically be shouting instructions at the physical hardware faster than the hardware can physically move.
Exactly. So Boeing's engineers aren't just building new parts. They have to intentionally dumb down modern tech.
That's crazy.
They have to reverse engineer the original functions using modern equivalents, but force those modern parts to operate at the exact voltage, resistance, and processing speed of an Atari-era circuit board. They're essentially translating modern digital processing back into 1982 analog mechanical reality.
That is wild. They have to engineer a modern part to act old just so the missile doesn't tear itself apart in flight.
Yeah, that's exactly what they're doing.
And the recent news details that this highly specialized remanufacturing work is going to be done at Boeing facilities in Heath, Ohio, and Fort Walton Beach, Florida. But this still leaves me with a lingering strategic question here.
Okay.
To connect this to the broader strategic chessboard, we know the U.S. military is already building a replacement.
Yes, the long-range standoff weapon, the LRSO.
Right, the LRSO. It's being developed by Raytheon.
Okay.
And the latest info shows it's going to be far stealthier, longer ranged, and compatible not just with the legacy B-52H, but also the brand new B-21 Raider stealth bomber.
Which is a huge upgrade.
Yeah. And it's making progress. The updates note that it reached milestone B back in 2023. which, for anyone unfamiliar with Pentagon procurement jargon, means it's finally out of the theoretical whiteboard phase. It's moved into actual, heavily funded engineering and manufacturing development.
It's a really critical milestone.
What?
Yes, it means the design is mature enough to start building prototypes.
Here's where it gets really interesting, though. If the LRSO is officially in development and moving forward, I have to go back to the economics.
Okay.
The Boeing contract commits $3 million in immediate fiscal year 2026 funding, with the total $49.5 million running all the way through June 2033.
Right.
If the shiny new replacement is coming, aren't we just throwing good money after bad by propping up this 1982 system? Like, is this $50 million remanufacturing contract just a desperate budgetary stopgap because the Pentagon failed to get the new missile ready on time?
Well, I totally understand why it looks that way on paper. But if we connect this to the bigger picture, it's really not a failure of timing. What we're seeing is the strict, unforgiving reality of nuclear geostrategy.
How so?
The cost, the complexity, and the sheer regulatory burden of fielding a brand new, certified nuclear weapon, it creates massive incentives to extend existing stockpiles as long as physically possible.
I hear you on the regulations, but $50 million to reverse engineer circuit boards. In an era of shrinking defense budgets, how is paying a premium for technological archaeology the most effective path forward?
Because you cannot simply rush a clean sheet nuclear design into production. The stakes are absolute zero tolerance.
Zero margin for error.
None. The latest updates mentioned this Boeing contract runs straight through the Air Force Nuclear Weapons Center, which is headquartered at Tinker Air Force Base in Oklahoma.
Right.
And that is a crucial detail. Any work that touches a nuclear-certified weapon, even something as seemingly mundane as swapping out a navigation circuit board, is categorically more demanding than conventional weapons maintenance.
Because they have to guarantee that the new part won't somehow trigger an accidental detonation,
Right.
or fail to arm when it's actually supposed to.
Exactly. They must verify that the weapon's reliability and its safety will not be compromised under any foreseeable abnormal conditions. Fire, a crash, extreme radiation, you name it.
That sounds incredibly rigorous.
It is. They have to satisfy both military operational requirements and Department of Energy safety requirements simultaneously. So every single modified component requires extraordinary levels of testing and political consensus before it's allowed anywhere near a live nuclear warhead.
So ironically, paying $50 million to reverse engineer ancient circuit boards and test them to death is actually cheaper, faster, and legally easier than trying to fast-track an entirely unproven nuclear weapon like the LRSO.
Far more cost-effective. Even if the per-unit engineering cost of remanufacturing these old controllers is incredibly high, it is still the most secure approach. And this brings us to why that timeline matters so much.
The 2033 date.
Right. You mentioned the Boeing contract runs through June 2033. Under current program schedules, the new LRSO is not expected to reach initial operational capability until the late 2020s at the absolute earliest. And even then, full replacement of the ALCM stockpile will take years into the 2030s.
So this Boeing contract is literally a timeline bridge.
It is a geostrategic bridge. Because the most vulnerable period for any global power is the transition window between major military capabilities. Why should you care about a delayed replacement timeline? Because every year the LRSO is delayed, the U.S. relies on older tech.
That makes sense.
If the ALCM stockpile was allowed to naturally age out and fail, say, in 2028, but the new LRSO isn't ready for wide deployment until 2032, you've just created a 4-year gap in your airborne nuclear deterrent.
And a gap like that emboldens adversaries.
Exactly.
If rival nations calculate that the air leg of our nuclear triad is essentially bluffing because the missiles are too old to fly, they might take aggressive actions they'd otherwise avoid. Your global stability is quite literally hinging on engineers in Ohio and Florida trying to successfully source and translate 40-year-old microchips.
That is the exact reality. By investing heavily in this sustainment contract, the strategic balance remains completely uninterrupted.
Zero gap.
Zero gap. The U.S. ensures there is absolutely no gap in the deterrent umbrella. They keep this Cold War ghost flying exactly as it has been, forcing adversaries to continue respecting that B-52 launch and leave capability until the LRSO is absolutely ready to take the baton in the 2030s.
So what does this all mean for us? If we look at the strategic chessboard, keeping a 44-year-old weapon flying isn't a sign of military weakness or technological stagnation like it might first appear. It is a highly calculated, incredibly necessary chess move. It's about maintaining a seamless wall of deterrence.
It is, but this raises an important question, something for everyone listening to really mull over after we wrap up today.
What's that?
Well, we just established that global deterrence currently relies on heavily modified 1980s hardware to hold the line until the 2030s, right?
Yeah.
But what happens when the original engineers, the men and women who actually built these systems and truly understand the eccentricities of this analog legacy tech, finally retire?
Oh, wow, that's a brilliant point. We can extend the life of the hardware with new circuit boards, but human memory doesn't get a life extension program.
Exactly. How much of our global stability is currently resting on fading institutional memory? As we transition deeper into a purely digital AI-driven world, the number of people who know how to successfully merge a 2026 microchip with a 1982 mechanical turbofan gets smaller every single day.
That is an incredibly heavy and fascinating thought to leave on. The bridge to the future is built on an increasingly fragile understanding of the past. I want to thank you directly for watching or listening today and for taking the time to truly understand the complex mechanics behind these seemingly dry procurement headlines. If you want to stay ahead of the curve and explore more of the hidden architecture of global security, be sure to check out our other deep dives right here on the Geostrategic Pulse. We'll see you next time.